Welcome everyone to my LeetCode bi-weekly contest 147 livestream. If you're here for solutions, jump ahead to 90 minutes in or use the timestamps in the video description. In a few moments, we'll be doing the contest live, answering questions, giving hints in the chat. So come join us every weekend for the contest. No code will ever be shared, but if you enjoy LeetCode content, do check out the rest of my channel. I have videos on different problems as well as hardest question 4s of previous contests. And as usual, like and subscribe to stay up to date on new videos. I have a bit of a voice today. Welcome everybody to the channel. If you're not familiar with the channel, I want to reiterate the rule about not sharing any code. We do not share any code while the contest is running. We never do that. We've never done it. That would be a threat to the contest competitive integrity. It is a contest after all. But immediately after the contest ends, we will go through the answers for all 4 questions. So make sure you stick around. The contest is about to start in another 4 minutes. Yeah, let's see if we can do some warm-up problems. Also make sure that my sound is working. Yep, seems to be working. Let me look at today's let me see, is this today's problem of the day? Today's problem of the day is not that difficult. It's length 3 palindromic subsequences. Yeah, these couple of weeks, the problem of the day have not been extremely difficult in the past 2 weeks. I guess because I don't know. I want to think it's because it's the holidays, it's Christmas time, it's New Year's time, so they know that people don't want to do really difficult problems. Yeah. Also, let me take a look at what I got for the last contest. So the weird thing about these contest ratings is that you don't always see a rating right away. You'll see a rating, but the rating is often not correct. You have to come back in a few days or even a week sometimes to see what you got. Yeah, as you can see, my rating is not that great. It's 1955. I'm trying to get it back to 2000. I was 2000 before. So hopefully with this contest, it's going to be easier. Or is this contest? Well, the contest being easier doesn't always help you. Hopefully this contest, yeah, will be able to go back to 2000. But we'll see. Let me see. Is there a problem in the last few days that was interesting? Oh, I can't see it. I think maybe last week's problem was interesting. This one. Okay, well, the contest is about to start soon, so I'm gonna focus on that. 29 seconds. I see people in the slowly coming into the chat to a channel. Welcome, welcome, welcome everybody. If you're not familiar with the contest's live stream, I don't show my code while the contest is running, so you may not see any activity on my screen right away. It might look like I'm not doing anything. I promise you I'm doing something. I'm just doing it on a different screen. So if you have any problems, make sure you ask me on the chat and I'll try to respond. Yeah, but otherwise I might not, because I don't show any code on stream, it might not look like I'm doing anything. Okay, so problem number 1, substring matching pattern. You're given a string S and a pattern string P, where P contains exactly one star character. The star in P can be replaced with any sequence of 0 or more characters. Return true if P can be made with a substring of S, false otherwise. String P and a pattern Okay, so there's a star somewhere in P. There's a star somewhere in P. And so, for instance, if S is LeetCode, P is EE star E. You can match EE here. You can match EE here. And then this E will be this E at the end. And star can be any number of any number of characters. Okay, so essentially what you want to do is do some kind of matching. It'll probably not be a good idea to try and find all the combination of things that can match star. That might get tricky. So instead, you probably want to find some occurrence of EE and some occurrence of E inside the string S. Okay, so with that, I'm going to leave you guys to work on it. Let me know if you want help, but definitely try it yourself first before asking for help. I'm going to work on this on my separate screen. Hey, Rohan Sharma, welcome back. I feel like I haven't seen you in a while. Oh, today's problems are supposed to be easier, at least based on the score. So it's 3, 5, 5, 6. Well, not that much easier, but at least they don't have like the 7 and 8 point questions. Exactly 1 star, so it's guaranteed to have a star. That's useful information. Huh. True, false, true. Okay. Actually, question 1 is harder than normal question 1s, but you know, it is a question 1, so it's not too difficult. All right. Oh crap. If you're new to the channel, welcome. Okay, so question 1 done. Question 2. Design Task Manager. There's a task management system that allows users to manage their task, each associated with priority. The system should efficiently handle adding, modifying. Oh, wow, this is a design question. Oh, interesting. Task Manager. So you will start with some kind of task. Initialize list of priority task. Wait, user task priority tuples. So there's 3 things: user ID, task ID, priority. As a task to the specified user with a given priority. And then you can add a task. Okay, you add a task. If you add a task, there's guaranteed that task ID does not exist in the system. So task ID is unique across all users. Edit task, new priority, update the priority of existing task ID to new priority. It's guaranteed that task ID exists in the system. You update the priority. Remove the task is guaranteed. Execute top. Okay, this is interesting. Okay, interesting. So basically what we want to do is we want to be able to so we have task, we have users. Okay, so exec top executes the task with the highest priority across all users. Okay, we have users. So we have a bunch of tasks. UID, TID, priority. So we have a bunch of tasks with priority, user ID, and task ID. Actually, the user ID is not that important because the task ID is unique across all users. And what we want to do is, at any point, we want to find the task with the highest priority. If there are multiple tasks with the same priority, execute the one with the highest task ID. So we want to execute the task with the highest priority. Well, if you store this as a simple list, but if you do something like a PQ, it may be hard to remove things. So these are some trade-offs that you can think about. If you want to do some kind of list, then finding the task with the highest priority is going to be tricky. You want to do some kind of priority queue, then it's priority queue, then it may be hard to remove or update the system. So you need something else. You need something a little bit clever to fix this. So I'm going to leave you to think about what that clever thing is. If you have questions, once again, ask in the chat. Let me know. UID, task ID, and priority. So we want to execute by highest priority. Okay, interesting. What about question 1? Hi, code crafters. So question 1, if you have questions, ask. If you have questions, ask. Yeah. Let me know if you have any questions. Just remember that we don't share code in this channel. So if you have specific questions, you tried it yourself and you got stuck, ask me. But if you just want the solutions, I will go over them at the after the contest ends, not right now, because the contest is still running. So the weird thing about these kind of system design questions I found is that you don't really know how good your design is. You might think it's good, but you gotta try it out, and then you actually know. Because in real life, you probably want to try out your design multiple times. You want to finish coding your design first, and then try and figure out whether it's good or not. That's in real life. Alrighty. So for question 2, you probably want to use some combination. You probably want to use some kind of combination of data structures to solve it. You probably won't be successful with just one data structure. But if you use multiple data structures, then you can use the strength from different data structures to help you. The tricky part is actually wrangling across those different data structures. How will you actually try to do that? Okay, so when there are multiple tasks with the same highest priority, execute the one with the highest task ID. Oh, interesting. So it's not just priority, it's priority and task ID. So you want the highest priority and the highest task ID. That's what we want to do. So it's okay. And what do you do when you update? Return the user ID. When you execute, return the user ID. All right, let's take this for a spin. Open bracket was never closed. Okay. Missed something here. So for any questions, will you show us the solutions? No, I don't show solutions, but ask if you have questions. Yeah, we don't show solutions while the contest is running. I will go over all the solutions after the contest ends, but not right now. So if you have questions, ask in the chat. Your questions, ask in the chat. If not, yeah, basically if you have questions, ask me in the chat. Yeah, question 2 is quite interesting. So question 2, you want to use some combination of list and priority queue to help you. So you might think of a list as your primary data structure to store all the canonical information. And then you might think of, whoa. Yeah, you might think of the list as your canonical data structure. And then you have to priority queue that will help you in addition to the list. List or dictionary of some kind. Okay, this is not correct. Oh, user ID, task ID, priority. So user ID, task ID, priority. User ID, task ID, priority. So if the user ID is, after executing, the task ID is removed from the system, return the user ID. Okay, execute the one the highest task ID. This is going to be a pain. I feel like this is going to be a pain. This is going to be a pain to debug. Okay. It's just a lot of different conditions. After executing, a task ID is removed from the system. And then, yeah, I'll help you. Hey, Sai Balaji. Yeah, I'll help you. No problem. Okay, let's talk about, let me see. I didn't understand first question properly. Sure, I'll just quickly go through the first question. So, first question, substring matching pattern. You're given a string S and a pattern P, where P contains exactly one star character. So example is this, right? P is EE star EE. The star in P can be replaced by any sequence. It can be replaced by any sequence. So EE star E can become EE1 BCA whatever E. You can replace this star with anything you want. It's like a wildcard, right? You can replace like this. You can replace it with TCOD if you want. Whatever you want. This is like a wildcard, right? This star matches anything. S is a string. And you want to see if there's a way to find P inside of S. So for instance, LeetCode. You want to find EE star EE. You have EE. You have star. And then E. And this star, if you turn the star into TCOD, you have find EE star E inside LeetCode. So that's the basic idea. So you have EE star E. This is like a wildcard matching. You want to find if there's a way, if there's something you can replace this star with, such that this P becomes a substring of S. That's the basic question. So how do you do that? Obviously, if you want to test different combination of star, that's never going to happen. That's never going to happen. What instead you need to do is to recognize that there's a left side and a right side to P, and you want to find the left side and the right side inside S. So you want to see, okay, I have my left side is EE, my right side is E, okay? Well, I'm going to go to my S and look for occurrences of E, EE, and E. So there's one here and there's one here. So since there's one at the beginning and end, you know that you can just replace what's in the middle with the star, and it'll be a substring of, and P will be a substring of S. That's the basic idea. I hope that's helpful. Question two is much longer. You actually have to read it. You're supposed to design a management system that will allow you to add, edit, and remove tasks. So this is pretty straightforward. You know, some kind of dictionary or list would help you do that. But the only tricky part is this exact execute top. You need a way to quickly find the highest priority task among all the different tasks. You need to find the highest priority task among all the different tasks. Yeah. That's the only tricky part. If you can do that, you're good. So I'm actually in the middle of question 2. I'm testing. So question 2 is a data structure. Sorry, it's a design problem. So it's gonna need a lot of testing. And it's kind of annoying, to be honest. So I want to make sure I test it to make sure it works properly, or at least it works the way I expect it to. Okay, so far it's working well. So edit is yeah. If you have any more questions, so Sai Balaji, I hope that was helpful to you. If anyone else has any more questions, just ping in the chat. Let me know. Okay, cool. Let's see if this works. Oh, I got wrong answer. Damn it. Remove and execute top. Now minus 1. Okay. Alright, cool. Question 2 done. At last. This really took a while. Because I want to be really careful and check for all the edge cases so I don't get penalized for time. But I end up getting penalized for time anyway. That's not great. Okay, question 3. Longer subsequence with decreasing adjacent difference. You're given an array of integer nums. Is to find the length of the longer subsequence seq of nums, such that absolute difference between consecutive elements form a non-increasing sequence of integers. Oh, wow. Return the length of such a subsequence. So you'll find the length of the longer subsequence. Such that the absolute difference between the consecutive elements form a non-increasing. Okay, you know what? I've realized that, half of coding is actually reading comprehension. So read the question, understand what it's talking about. It's not always clear, but if you have all this like a more precise and mathematical notation, then it becomes clearer. So this also means you need to learn how to read precise mathematical notation like this. In real life, of course, PMs write documents that are really bad, so you need to understand what they're saying. Okay, so example is 16, 6, 3. So 16 and 6, difference is 10. 6 and 3, difference is 3. So they're non-increasing. Non-increasing just means decrease or stay the same. So this decreased, 10 and 3 decreased, so we're good. So 6, 5, 6, 5, 3, 4, 2, 1. This is 1, this is 2, this is 1, this is 2, this is 1. Then in this case, the best, so this is not non-decreasing, right? If you look at the gap between adjacent pairs of numbers, the gap between them is not non-decreasing. Okay. And then the best that we can do is actually 6, 4, 2, 1. So the best we can do is 6, 4, 2, 1. So 6, 4, 2, 1. So 6 and 4. The gap is 2, 2, and 1. So this is non-decreasing again. Okay. Likewise, the gap here. Likewise, the gap here is this. Yeah, absolute difference. The best we can do for here is 10, 20, 10, 19, 10. We get rid of the last 20. And then we get 10, 10, 9, 9. So notice that we're talking about the absolute differences, the gap between adjacent numbers. So for instance, 6 and 5. 5 is smaller than 6. The difference is 1. 3 and 4. 4 is bigger than 3, but the difference is still 1. So we're talking about the absolute difference between two numbers. So if you see a question like this, the first thing you want to do is some kind of dynamic programming. And that's what I'm thinking also. Hints for third one. The third one, hints for third one, you probably want to do some kind of dynamic programming. I will say that one more hint, based on it's just a contest trick. If you see something like this, okay, the length is pretty big. But more importantly, the numbers are between 1 to 300. So you have to, most of the time, the best solution will make use of the fact that the numbers are between 1 and 300. Yeah, to help you. So that's kind of your hint. And this is a medium question, so it hopefully is not too difficult. Yeah, you probably want some kind of dynamic programming. Because the differences because nums is from 1 to 300, the maximum absolute difference is only 299. So it's not a very big number. So that's kind of a hint to help you. So try yourself. If you need help, in a few minutes, once I've gotten my solution down, then I'll come and maybe give you a bit more hints. But again, no code. Don't share any code. Do not share any code on this channel. I know I can do it in n square. Yeah, if you can do it n square. Wait, if you can do it n square, then you should be done, right? Because 10 to the power 4, if you do it in n square, is okay. You will not get TLE. If you can do it in n square, do it in n square. I'm pretty sure that if you can do it in n square, you won't get TLE. But make sure it's n square is not 2 to the power n. Because you're talking about if you're talking about subsequence, not a subarray. You're talking about subsequence, so you can jump like 6, 6, 4, 2, 1. You see this 6, 4, 2, 1? This is 6, 4, 2, 1. So they are not contiguous. So make sure you're aware of that. So the maximum distance is okay. Let me just think aloud here a little bit. So, let's say 6, 5, 3, 4, 2, 1. So I'm at 6. What do I know? I know the longest sequence I've seen is of length 0. The longest sequence I've seen is of length 0. Okay. Of length 0. Its last number is nothing. And then it's like absolute difference. Yeah, it's absolute difference. Or let's put it another way. The last number I've seen is nothing. It's absolute difference, because the absolute difference needs to be needs to be between consecutive elements. Okay, the absolute difference needs to be non-increasing, so it's kind of decreasing, right? So the first sequence is like, you know, we have seen a sequence that ends with like x, which is an unknown number. Its smallest absolute difference is infinity, and is of length 0. When you get to 6, you can change this to 6. The absolute difference is 0, and is of length 1. Right? When you get to 5, you can either take 5. Its last number will be 5. The absolute difference is going to be 1. And it's going to be length 2. Or okay, so the best one I've seen is length 1. Or you can start your own. The best absolute difference is, yeah, there's no absolute difference. Actually, this is infinity. Okay. And then you can sort of branch from there. So you need some kind of way. So I probably need some kind of way to memorize this. So that I don't see this same number again. So basically, this is okay. So this is the current absolute difference I have. So this is the current absolute difference I have in my sequence, the last absolute difference. So if I'm just starting off my sequence, then you know, it doesn't matter. This number over here, okay, I think I got it. Yeah. So basically, you sort of find for each. Okay. For each number here, let's say something ending, if your current sequence ends with 6, right? What is the highest absolute difference with the lowest score? With the longest score. Highest absolute difference with the longest score. And because okay, I think I'm rambling a little bit. Yeah, so I don't give solutions, but the basic idea is what you see on the board. The basic idea should be what you see on the board. So you probably want some kind of dynamic programming solution. At each point, you see a new number, you think, okay, I can either add it to the sequences I've already seen, or I create a new one. If you create a new one, then your new sequence ends at 6. It's like last absolute difference is infinity, and is length 1. Yeah. If you don't create a new sequence, you can look at the existing sequences. What are they? And then you can see if you can sort of like add to it. Yeah, I think that's the basic gist of it. Bear in mind the largest difference between them is 300. So you can use 300 as a proxy for infinity. One intuition. Okay. So let me see. One intuition, basically looks like this. You have your P, right? Your P has a left side and right side and a star in the middle. So you want to look for the left side in S. You want to look for the right side in S. If you can find an occurrence of the left side and an occurrence of the right side that is separated by something, you can turn your star into that something, and this will be true. If you cannot find an occurrence of the left side, or you cannot find the occurrence of the right side, or the only occurrences you have are the other way around. So, for instance, if you have something like this, then the only occurrence of EE is here, and then the E is like here, then this will be no. This will be yes, because you find the occurrence of the left hand side, the left side, the right side of your P. You split them left side and right side, and then you try and find them in S. So that's all I can tell you. Okay, that's all I can tell you for now. Yeah, I'm also doing tree using memoization. So the memoization is tricky. It's not just memoization. It's not just memoization, because for sequences ending with whatever number, right? With sequences ending with, whatever number, 6 or 3 or whatever, there are two things associated with this sequence. What is the last absolute difference you saw, and what's the length of the sequence? So you want to make sure for each absolute length you have, you just keep the longer sequence. That might be the reason why you have a TLE. I'm not sure. I'm still working on mine. Man, I sure hope I can finish this. In time. Yeah, I don't think I have time to finish question 4. Either extend an existing sequence. So yeah, I think if you do it right, there can be like little opportunities to make it faster. So, memoization will make sure that you don't. Yeah, memoization will make sure you don't end up with like a very large number. But you need there are some little tricks on the way to make things a little bit faster. Is what I'm saying. Of course, I'm also still working on it. I haven't got the solution yet. I'm halfway through, so take what I say with a grain of salt, with a lot of salt. for diff. To dp plus diff. Okay, let me see. Memoization. Any hints for third? Yeah, hints is on the board. It's some kind of memoization, I think. Let me see. I'm also trying to get this to work. Sorry if I'm quiet. If I'm quiet, that means I'm working on my stuff. So please don't be super surprised. Well, or try not to be super surprised. Okay, I'm trying to debug. So this is 1. One longest difference with voila sequence 1. Okay, cool. So let me see, 0, 1. So last sequence is 1. Yeah. Okay. I think I got it. Okay. Six. Zero, 1, 2, 3, 4, 5, 6. Okay. So 2, 3, 4, 5, 6. My diff is thus equals to 1. So either you can start 1 on your own, or you can have 2 length. Two. The last sequence is 2. Okay. And then when you see a 3, sorry, if I'm being quiet, it doesn't mean that I'm not doing anything. I'm actually on the other screen. Any hint for memorization in third? Yeah. This is kind of tricky. So the way I'm doing it, I'm using a 300 by 300 table. So if you memorize you basically have to record 3 things, right? You record essentially the last number in the sequence. You record the last absolute difference in the sequence, and then you record the length of the sequence. So I'm trying basically 300 by 300 table. You tried it? I'm still trying it. I'm still trying to debug. You getting TLE? Okay. Yeah. So 300 by 300 table. Yeah. I don't know. Maybe instead of using a table, you can use a dictionary. I wonder if dictionary is faster. I wonder if dictionary is faster than the 300 by 300 table. Yeah, but I'm still debugging mine, so I'll let you know if it works. So 3 is 1. Yeah, I think there should be some faster way of doing this. So let's say is 4. So my diff will be 2. Yeah, I'm still debugging my table. This is a little bit annoying. So my diff is, so 4 should not be of length 4. If so ending with 4 for 6 is going to be 2, so there's only 1, so this would be 2. For 5 it's going to be 1. For 5 it's going to be 1. This is going to be 3. 2 ways div 2 of div 1 2 ways of div 1, and then 3 is, wait, 3 ways of div 1. Okay. Yeah, giving contests, but in every contest I'm able to do first. Where am I going wrong? Well, Nobido, you're not doing anything wrong. The contest is, I have noticed the contests are harder and harder. Yeah, so you shouldn't think of the contest questions as a way to get better at programming. Contest questions, especially question 3, question 4, are ways to get better at doing contests. Yeah, if you want to get better at programming, just do the normal, the sort of easy and medium questions on LeetCode. Don't worry about the contest. Contest questions are really hard. They are not sort of emblematic of, they're not, good examples of how you would do in a real life programming problem. 3, 4, 5. 3, 4, 5. Interesting. I'm also getting TLE with the 300 by 300 array. Let me just take a look at let me take a look at the chat. Yeah, I know there are patterns. Yeah, there are patterns to these. Okay, so it depends on what you want to do. If you want to get better at programming, LeetCode is not the way. If you want to get better at technical interview, you should do LeetCode, but only do the medium questions, easy and medium questions. The hard questions and the contest, especially the contest, very hard questions, those are not realistic examples of the questions you might get at an interview. So if you cannot do them, don't worry about it. The contests, after a certain point, is just for fun. So straight Ravat, don't be frustrated. Don't worry if you don't get it. It is what it is. Yeah, it is what it is. So don't worry too much about it. I'm doing final research. Yeah. Believe in the process. Yeah. So I would strongly recommend, if you want to get better at programming, I would strongly recommend doing projects rather than grinding LeetCode problems. Because in real life, you'll be working on actual projects. There's a book that I like a lot called Automate the Boring Things. So that book has a lot of like projects that you can do. Yeah, don't worry about LeetCode problems if you want to get better at programming. Especially the difficult ones. The difficult ones are just for people who enjoy contest problems. They're just for people who enjoy puzzles. Oh, very nice. You solve it. Very nice, very nice. Yeah, I still got a TLE. I don't know why I got a TLE. Because I thought, yeah, I don't know. I thought my way was pretty fast already. Yeah, I'm switching from array to a dictionary. I don't think it's gonna matter. I really don't think it's gonna matter, but we'll see. We'll see. Yeah, I didn't manage to get it done. Yeah, that one was... Yeah, max adjacent div can only be up to 300. Yeah, so I did it with 300 by 3. I couldn't do it with 300 by 300. I also got TLE. I got time limit exceeded. Yep. 563 out of 583. Use DP n times 300. Use DP n times 300. Oh, interesting. N times 300. Okay, and I guess at every point you sort of find... Oh, so you keep the best that you have seen so far. Is that what you do, Lord Voldemort? Yeah, I guess that works. Okay. Yeah, hi, welcome back to the chat. Okay, so the contest has ended. For, I'm going to do my usual plug, which is, if you enjoy my channel, before you guys all run off, I do appreciate if you just click the like button on the stream. If you enjoy my channel and you want to come back next time, you can like and subscribe to the channel. This way you will know when's the next time I will be streaming. I stream every weekend. I stream the bi-weekly contest if it's there. If there's no bi-weekly contest, I'll stream the weekly contest. So I hope to see you guys next week. Let me read the chat a little bit. Red Finance. Hey, Red Finance, welcome back. Haven't seen you in a while. I didn't solve it, but here's how it went. Basically, you select index diff so far. Yeah. 0 maximum value if that number is present. Yeah. To n plus 1 is the diff with the new is less than the 1 equal to max diff, you take that path. Yeah, you sort of find the... Yeah, I don't know. I thought my path was thought mine was quite optimal. Yeah, you had to store the last diff you saw, the diff so far, because the diff has to go down, right? The diff has to go down, so yeah. Well, anyway, let's go on and talk about the questions. Actually, I'm really happy to see all of you here. Welcome back to the channel. I haven't seen Red Finance in a while, and it's good to see I and Rohan Sharma back again. So let's quickly talk about solutions for today's problems. We're gonna start with question. Actually, no. Before that, I gotta do my LeetCode standard YouTube. What do they call this? Like interfacing or something? Yeah, to do my standard YouTube announcement, so the video looks right to people who jump ahead to this part. We are discussing solutions for LeetCode bi-weekly contest 147. Jump to specific questions using timestamps in the video description. Please check out the rest of my channel. If you enjoy LeetCode content, like and subscribe to stay up to date on new videos. Alright, so today's contests, I managed to do 2 out of 4. Not great, but it is what it is. As usual, remember that these contests are not emblematic of real-life problems that you see in software engineering, nor are they necessarily examples of what you encounter in a technical coding interview. So if you want to get better at those things, make sure you do the regular LeetCode problems. Make sure you work on your own projects. Don't just work on contests. Contests are really for people who want to have fun. If you don't do well in contests, it's fine. It's fine. Contest is for people who enjoy contests. Okay, so question 1. Question 1, string matching pattern. Question 1, substring matching pattern. You are given a string S and a pattern P, where P contains exactly one star character. The star in P can be replaced with star in P any sequence of 0 or more characters. So, for instance, if your P is E star star E like this, E star E, this star can become anything. It's like a wild card. So if you want, you can say A, B, C if you want. You can also more productively, in this case, replace the star with T, C, O, D. You can replace it with anything you want. In this case, you replace it with T, C, O, D and you get E, E, T, C, O, D, E. P will become a substring of S. So what we want to do is the star in P can be replaced with any sequence of 0 or more characters. Return true if P can be made a substring of S and false otherwise. We want to see if there's a way we can substitute something, the star, replace it with something, and get a substring of S. Not S exactly, but a substring of S. So obviously, if you want to try every possible combination of replacement for star, that's not going to be intractable. Instead, what you probably want to do is you want to look at it in terms of the pattern. So we know there's exactly one star, so there must be a left side and there must be a right side. Okay, so P S equals this, right? So there's a left side and a right side, and what you want to do is you want to see the first occurrence of the left side in S and the last occurrence of the left side in S, of the right side in S. If the left side of the pattern in P occurs in S and the right side also occurs in S, and the first occurrence of the left side is smaller, is on the left of the last occurrence of the right side, then you can replace everything in the middle with the star and you will get a substring. So it boils down to finding, first you have to figure out the left and the right side of the pattern P, and then you have to find them in S. Okay, so in Python this is actually quite simple because there are a lot of useful functions. In Java and C++, there are probably also equivalent functions. You just have to know what they are. So what the first thing I do is I take I find the index of star in P, and this allows me to do P1 and P2. P1 is the left side, so this is P1, and P2 is the right side. Okay, once I have P1 and P2, I look for P1 and P2 in S. So this is left, and this is right. Okay, if either one of them is not found, then I return false. So if either of these two pieces are not found, then they're false. If they are found, then I want to make sure that the right side is on the is greater than the left side. So the right side must be on the, after the left side, and not only that, the index is such that the difference between the starting indexes are at least length P1. It has to be at least length P1. Otherwise, you might get a case of this, where this is the left and then this is the right, and it overlaps, and then that's not going to result in a way where it can turn P into S. So if you, as long as you check this will give you the answer. I think there shouldn't be any questions. Let me read the chat a little bit. I don't have time for 4 either. I also did 2 out of 4. Yeah. Read 4 wrong. Yeah, you know what? You and me both. If you notice that I also got penalized. For me it was question 2. So don't be ashamed if you got something wrong. It is what it is. All right, question 2. Design task manager. There's a task management system that allows users to manage their task associated with a priority. The system should efficiently the system should efficiently handle adding, modifying, executing, and removing tasks. So let's look at the details. It's a lot of text, right? So most of programming is reading. So first thing you do is to initialize the task manager list of user task priority triples. So every task is 3 things: is a user ID, task ID, and the priority. You add tasks to a specified user with the given priority. You add a task. Okay, that's straightforward enough. Task ID is unique. So we know that task ID is unique, is a unique identifier. You can delete a task and add it again, but at any one point, there's only one task in the system with this task ID, so it's unique. Edit. You can update the priority of the existing task to a new priority. It's guaranteed that task ID exists in the system, so we'll not give you erroneous updates. And then remove, you just delete the task ID. So these 3 are very standard functions. If you look at this, you might think the easy way or the straightforward way to do this is some kind of dictionary or some kind of hash map. Dictionary in Python, hash map in Java, and I don't remember the C++ equivalent. So some kind of hash table, some kind of hash table where you have a task ID and then it maps to a user ID and priority. Okay, that's your basic data structure. To handle those first 3 things efficiently, you want to add, very simple, you just look up the task ID, you modify this. You want to edit, well, look up the task ID and change the priority. You want to remove, look up the task ID and delete the whole row. This is straightforward enough. Now, the only thing that is tricky is the last part. The last function. The last function is exec top. Execute the task with the highest priority across all users. If there are multiple tasks with the same highest priority, execute the one with the highest task ID. After executing, the task ID is removed from the system. Return the user ID, and if no task, return -1. Now, why is this tricky? Is if you do a normal hash map / dictionary, you want to find the highest priority task, it's going to be an O(n) operation. This is going to be very expensive. If you look down, you know that there can be a lot. Yeah, there can be 10 to the power 5 tasks. So you definitely don't want to do that. You don't want to do that many times. So that would be a bad idea. So instead, you need an effective way of finding who the highest priority task is. So in addition to this will be a primary data structure. You need a secondary data structure. And actually, this is a very common pattern even in real life programming, not just in LeetCode question. You need a secondary data structure to store priorities. So for this, you need some kind of heap or priority queue. You need some kind of heap or priority queue. So priority queue will store a priority and task ID pair, and it will sort them with the highest priority and then the highest task ID. Because if they're same priority, execute the one with the highest task ID. So you need 2 data structures to do this. Or I think the best way to do this is the easiest way to do this is with 2 data structures: priority and task ID. Now there's a catch though. There's a catch that priority queues are very hard to delete from. You can add to a priority queue, but deleting from that priority queue is a pain. So what we want to do is you want to keep adding things to priority queue, but when you delete them from the main table, you don't delete, you leave it in the priority queue. Just leave it. Don't throw it away. Don't delete. Don't remove. Don't remove things from a priority queue. When it's there forever until you pop it. Just leave it there. When you're called to execute, what you want to do is to pop. But when you pop, you take one more additional step. That is, you want to verify that this priority and task ID still exists. That's why you still need a primary data structure. Your primary data structure keeps track of the ground truth, right? This hash hash table / dictionary keeps track of your absolute truth. This is actually what's happening. The priority queue can be outdated, it's fine. It's got a bunch of things that have been deleted already, their priority changed already, it's fine. I just need to know what was the highest priority task. If I want to find the highest priority task, I keep popping. I find a priority task ID pair that is current. That has not been changed or modified. So that's the basic idea. So how do you actually do this? The code looks something like this. So I have a list of tasks. The task is the actual ground truth, right? The task is this thing over here. The task is is a hash table. When I have a new task, I add it to task. So self.taskid equals to task ID UID priority. This can be a little bit reduced. It doesn't matter. It's not a big deal. At the same time, I also append this to the heap. So I add this to the heap. And what I add to a heap is minus task prior minus TID. Basically, because Python's heap always sort from smaller to largest. If your heap allows you to have a comparator, you can use that comparator. Okay? So when I will add to the main hash table. So I update my actual ground truth. And I also add to the heap. When I add it, I update the hash table, and I also add to a heap. I don't delete the old one. The old one is still there. I'm just adding a new pair. When I remove from the hash table, the ground truth, but I don't touch the heap. So this way, the heap will contain a lot of old tasks that have been updated, that have been deleted. I don't care. Doesn't matter. When it comes to executing, first, of course, I check any task. No task, return -1. When it comes to executing, I would repeatedly pop from the heap. That's why there's a while, there's a loop here. I'll keep popping from the heap. And then, whatever I get from the heap, I want to check that the task ID still exists in task. And then I want to check that the user ID and the priority are still what it is in task. Okay? When I pop from the heap, I want to take an extra step to check that this item in the heap is still correct based on my hash table. My hash table is my ground truth. This is the absolute truth. This is exactly what is true in the heap, in the system right now. The heap contains a lot of things, tasks that are dead or changed. I don't care. I'm going to leave them there. I keep popping. When I execute, I take the top item in the heap. I keep popping and find a task. I find a task that is actually correct. And then I would delete the task and return user ID. So I'm actually going to, use it. So that's the main crux. So you have a secondary data structure. That's the main trick. Your primary data structure that keeps the ground truth. The secondary data structure, it makes it easier to look up certain properties that you're interested in this case, the priority. The secondary data structure does not need to be 100% accurate. In this case, I will double check with the primary data structure before I actually return the user ID. So this is going to be fine. So this is the basic strategy. If you do it right, the code should look like something like this. And it should pass. Okay, now let me take a look at the chat. Fix your... So Danny Staples, I wasn't able to solve any of the problems. Can you give me some suggestion? I just started my DSA. Okay, Danny Staples, my suggestion to you is don't do the contest. If you cannot do even question 1 in the contest, there's no point doing the contest. Do the daily problem. Actually, even before you do the daily problem, do the LeetCode easy problems. Let me see if I can find it. Yeah, the study plan. Go to the study plan, the top 150 problems. Do the easy ones. Just do the easy ones. Don't do anything else. Do the easy ones. Forget the medium, forget the hard, right? Just do the easy ones. And then if you want to find the easiest ones, find those with, you can sort them based on their acceptance rate. Find the easiest problems to do first. Don't worry about the more advanced problems. If you want to get better at programming, you have to tackle things at your level instead of trying to do the really, really difficult things. It's just like when you learn to play the piano, you play the easy songs first, right? You don't play the hardest song and then you get stuck. Okay. You just started. Yeah. So today's question 1 was hard. Even question 1 is hard today. And I think the contest questions, I noticed, are getting harder and harder every week. So, yeah, don't worry if you don't. In fact, I would recommend if you're just starting out, don't do the contest at all. Which is sort of self-defeatist because I run a contest stream, but you can still tune in and watch me if you like, and hang out if you like the content. Yeah. Do the daily problem. That's good advice for sure. Yeah, that's definitely good advice. Okay, so next problem. As you guys know, I'm very passionate about telling people not to do the hard problems. And if you want to get better at software engineering, I've said this before many times. Do projects. Don't just do LeetCode. LeetCode will not help you become a better programmer. It'll help you become better at small things in programming. If you want to become an actual better programmer, you need to do projects. Okay, question 3. Longest subsequence with decreasing adjacent difference. So you are given an array of integer nums. Your task is to find the length of the longest sequence of nums such that the absolute difference between consecutive elements form a non-decreasing integer sequence of integers. So this is one of the things about programming problems. Is also a reading comprehension problem. First, you need to tackle the English, and then you tackle the programming, right? It is what it is. It's true like that in real life too. So let's look at the actual definition. So for sequence seek 1, 2, 3 all the way to m, seek 1 minus seek 0 absolute is larger or equal than seek 2 minus seek 1 absolute blah 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 blah. So for example, if our sequence is 16, 6, 3, okay? This and this, the difference is 10. This and this, the difference is 3. So this is a non-increasing sequence. Non-increasing just means decreasing or stay the same. So you want this difference, this sequence of absolute differences to be non-decreasing. It has to keep going down or stay the same. So if your sequence is 6, 5, I'm looking at this one, 3, 4, 3, 4, 2, 1, okay? The differences between them, and this is absolute difference, not actual difference. The difference between this is 1. The difference between this is 2. The difference is 1. Notice this absolute difference. Doesn't matter it's 6, 5 or 5, 6. It's still 1. The difference between this is 2. And the difference between this is 1. This is not a non-decreasing sequence because it goes 1, 2, and then 2 goes down to 1. So that's not good. So this is a decreasing. You want this to be non-decreasing. So the best way to turn this into a non-decreasing sequence is to take the subsequence 6, 4, 2, and 1. Okay? Notice that this is a subsequence. That means you just delete things. It's not a sub-array. It doesn't have to be contiguous. I can take 6 from the beginning. I can take 4, 2, 1 from the end. In this case, the difference, 6 and 4 will be 2. The difference between this will be 2. And the difference between this is 1. So now you notice that the sequence of absolute differences are non-increasing. So they are going down or they are staying the same. 2, 2, 1 is going down or staying the same. Alright? So this is what the question is basically asking for. This is what the question is asking for. So if you want to do it by brute force, how long is this going to take? Well, how many subsequences are there of length n in a sequence of length n? Well, either you take or you don't take a number, right? So 2 to the power n. 2 to the power n is very, very slow. And since the length is n is 10 to the power 4, 2 to the power of 10 to the power 4 is way too slow. It's going to take forever. So that's never going to work. So instead, you need some way of doing this quickly. So whenever you see a problem like this, when you see some kind of sequence, the first thing I think of is dynamic programming. So dynamic programming you need base case and you need the n+1 case. So if you can solve the problem, you need a base case that's easy to solve, and you need to make it such that if you can solve the problem for n, then you can solve the problem for n+1. You have to redefine the problem such that, so most of the challenge of dynamic programming is to redefine a problem such that when you solve the problem for length n, it becomes easy to solve the problem for length +1. Okay, so look at our problem here. 6, 5, let's say I have 6, 5, 3, 4, 2, 1. Okay, if I, let's say, solve the solution for the first 3 numbers, would it be easy for me to extend that solution to include this 4 here? Well, actually not that easy. If I just find the solution, if I just find a longer subsequence with the non-increasing absolute difference for the first 3 numbers, I can't find it easy for 4. Because I don't know what the last absolute difference is. I don't know what the last number is. Okay? So you need something a little bit more than that. What you need to know is you need to know not just the best possible solution, you need to know the solution ending with different numbers. So let me just extend this a little bit. Yeah. So you ending with different numbers. So for instance, if I know not just the length of the longer sequence in 6, 5, and 3, I also know that for sequences ending with 6 and whose last absolute difference is undefined, the best length is 1. For sequences ending, because there's only one sequence, right? 6, that's the only one. For sequences ending with 5, whose the best I've seen so far, the absolute difference is 1. So 6, 5 is the best I've seen so far, as length is 2. Okay? For sequences ending with 3, 6, 3, and 5, 3 are both valid. 6, 3, and 5, 3 are both valid. But 6, 5, 3 is not valid because 6 and 5 is 1. This is 2. So 6, 5, 3 is not valid. So 6, 3, and 5, 3 are both valid. So the best I've seen so far ending with 3 is of length 2. And the highest absolute difference I have seen is between 6 and 3. So for sequences ending with length 3, sequences ending up to this point, the sequences ending with 3, with absolute difference of 3, the best length I've seen is 2. Okay? So if you have something like this will actually help you solve for 4. Because now when you come to 4, you can say, you don't have to look at this anymore. You don't have to look at this above thing anymore. when it comes to 4, you can say, okay, 4, there's 2 ways I can do it. Okay, I can either, let me see if I can get a bit more real estate. So when it comes to 4, there's 2 ways I can do it. One is I'm going to start from 4. 4 is going to start from a sequence. My absolute difference is like infinite. My length is 1. Or I'm going to take 4 and I'm going to attach it to something else before. So let's compare 4 and 6. 4 and 6 absolute difference is 2. 4 and 6 absolute difference is 2. Okay? And if I attach 4 to 6, my length, because the best difference I have for 6 is 1, my length is now 2. Well, what about 4 and 5? 4 and 5, the absolute difference is 1. 4 and 5, the absolute difference is 1. Okay? If I attach myself to 5, the longest sequence I've seen for 5 is 2. If I attach myself to 5, my best length is now 3. What about 4 and 3? 4 and 3, the absolute difference is also 1. Okay? Just like this one. That's better than absolute difference here. So that's okay. Its length, well, is 2 plus 1, also 3. So this tells me that I can attach myself something 5, 4, something 3, 4. They are both okay. So now I know that I can have a sequence of length 3 whose last number is 4 and whose last absolute difference is 1. Okay? So I'm going to keep creating this table. How big is this table? In first glance, you might say this table is actually 2 to the power of n size, because every time you sort of can attach or you don't attach, right? But the catch is these numbers are actually repeated. There are only 300 numbers. So the numbers can be repeated. There are only 300 numbers. You scroll down here. There are only 300 numbers. So the numbers can be repeated. So after a while, you'll sort of replace existing rows instead of creating new rows. The second thing is you will only add if your absolute difference is you only add a record if its length given its sequence, the last number and the absolute difference, only if its length is larger. So for instance, if later on I find another 4 sequence ending with 4, its absolute difference is 1, but its length is only 1, then I'm not going to replace this. I'm only going to replace this if this is 4 or longer. Right? So because the numbers here are only up to 300 and the absolute difference is only up to 300, the maximum number of rows here is going to be 300 times 300, which is 900. So this is not going to be a very, very complicated array. It's not going to be 2 to the power of n. So that's the basic idea. That is the basic idea. So remember, for dynamic programming, the criteria is if you can solve the problem at length n, you should easily use that answer to solve n plus 1. If you solve the problem as given, which is find the longest length for length n, you cannot use that to easily solve n plus 1. You need more information. So that's why we're building this table here, to have more information. Okay, so basically the code that I have essentially writes out the table. So I have dp. dp is an array. If this is new, then I just create I just say what happens if I'm starting a new a sequence at this index. Okay, and then what I do is for all the last numbers, so I look at all the last numbers I've seen, right? If I'm at 4, I'll look at 6 and 3 and 5. I'll look at all the last numbers I've seen. I check my absolute difference with them. So 4 and 3, the absolute difference is 1. Okay, the absolute difference is 1. So I need to... Yeah, the absolute difference is 1. So I need to check all the ones. Everybody with absolute difference ones. What is my best length given a... Yeah, what's the best length I have, right? So this is what updates the new row in the table. And so at the end of what you do once you have that like nice big table, unfortunately, oh yeah, nice big table is here, it's still here, great. You nice big table, what you want to do is you want to find the largest number in this column, the largest length you've seen so far. So if you complete this table, you'll find the largest length is actually 4. Yeah, so that's the basic idea. Let me see if there are any questions here. Current diff. So this actually did not pass. Unfortunately, I got TLE. So I need to find out what actually is to make this better. I think it's because, so my suspicion for why it didn't pass is because I'm keeping multiple versions of the same number. So for sequences ending with 4, I keep like absolute difference is infinity, 2, 1. I don't actually need to keep all of them. If, for instance, I found, if for instance I found something ending with 4, whose absolute difference is 3, and the length is 10, then all these things can go away, because all of their absolute difference is worse than me, is smaller than me, and their lengths are smaller than me. So all of these guys can go away. So yeah, that's what I'm thinking. I don't know what's the best way to do this though. I have to think about it. I'm actually very surprised that it didn't pass. It might be a bug. It might also be a bug on what I'm doing, because what I'm doing is like 300 times 300 times n, which in theory should be quite fast. Yeah, max diff is 300. Yeah. So the absolute diff, is so it's n times max diff. Yeah. Well, actually, now thinking about it, I don't actually need to... Wait, now that I think about it a little bit. Do I need to keep last num? I do need to keep last num. I need to know what the last number is. Yeah, I don't know. Yeah, I don't know. Max diff. I don't know how to make this faster. I really don't. I have to think about it a little bit. Okay. Let me just briefly look at question 4. I didn't get a chance to look at question 4 during the contest itself. But 300 by 300 by n. Yeah, they shouldn't pass. Yeah, I was hoping to sneak it in. I was definitely hoping to sneak it in, because n is 10 to the power of 4. If n is 1000, then I think it will pass. Okay, so I didn't get a chance to look at question 4, so I'm going to look at it now, and then I see, and I'll talk a little bit about what comes to mind. So question 4, maximize subarray sum after removing all occurrences of one element. You are given an integer nums. You can do the following operation at most once. Choose any integer x such that nums remain non-empty on removing all occurrences of x. Remove all occurrences of x from array. Return the maximum subarray sum across all possible arrays. So for instance, let's say nums is this. Let's say nums is 10. maximum subarray sum. Wait a second. You can choose any integer x and remove maximum subarray sum. Oh, okay. So you want to know what's the maximum subarray sum? Okay, so let's say it's this. You have the following arrays after at most one operation. Or the original maximum subarray sum is 4. This is a subarray. If I delete all occurrences of -3, the maximum subarray sum is still this. If I delete all occurrences of -2, if I delete all the -2, I get this. Then my maximum sum is this. Deleting all occurrences of -1 give me this. Yeah, so basically you want to see if you delete a particular number, what is the maximum subarray sum? Okay, interesting. So it sounds like a sliding window with extra steps. Sounds like a sliding window with extra steps. Okay, so unlike the previous problem, you'll notice that nums I is very large. It can be 10 to the power 6 or minus 10 to the power 6. So that tells me that if you want to make an array or a DP or whatever with nums I as an index, you are going to fail because nums I is extremely large. That was actually my first thought. My first thought was find the, nums I and sort of work backwards. So it seems like a sliding window problem. This seems like a sliding window problem. I think. It seems like a sliding window problem. But your window should contain the sum. It should also contain the frequency of all the numbers. It should contain both sum and frequency. So the problem I have with sliding window is that it's not monotonic. Now it's not monotonic. Yeah, I don't know. This is what I'm thinking of. So as you slide, so let's say you have -3, 2, -2, -1, 3, -2, 3. So let's say you're here. Your best sum is 2. And your frequency is... Yeah, I'm to think about it. This is not super obvious to me. I don't think sliding window, like the normal sliding window, works very well because it's not monotonic. As you add things, you can actually become, you can become better or worse because you change the frequency, right? So now you find a different guy to subtract. Yeah, I got to think about it a little bit. Sum of the subarrays between two numbers quite easily with prefix sum. Okay. Yeah, that's true. You can use a prefix sum. But the thing is, so my problem with this is frequency. Oh, actually you can use the frequency. You can use the frequency as... Yeah, you need a frequency table because in the prefix sum, if you pick a particular window, if you have a prefix sum, you need to know like what numbers you can delete. You know what I mean? Which number to delete? Which number will be most useful to delete? So the problem I have with that approach is that the problem with the frequency table approach is that the nums I is 10 to the power of 6. So the frequency table can get extremely large, and you don't want to do that. Yeah, so the prefix, yeah, I don't know. So originally this is what I'm thinking. Is you have like a prefix sum, but not just a prefix sum, but also a prefix frequency, like a prefix frequency table. So you have -3, 2, -2. So at -3 you say, okay, your sum is -3. You have -3 times 1. At 2, your sum is going to be -1. And then you have -3 times 1, -2 times 1. And so on and so forth. And then what you can do is -2 is going to be -3. And what you can do is you take this and then you subtract this. You find the smallest you have here. But you can't do that. You cannot find the smallest you have here and subtract. Because these things matter. These things here matter. And then if you want to search through this, it's going to be order of nums I. And because nums I is very large. If nums I is small, then you can do it this way. Then you can just do like the standard prefix sum. Except that you also take into account like these extra things here. But I don't think you can do that. I don't think you can do that because, yeah, it's just kind of big. Yeah, I don't know. I have to think about it a little bit. Nothing comes to mind right now. Let me just take a look at. Is there hints? There are no hints. There are hints. Use a segment tree data structure to solve the problem. Okay. Alright. Segment tree. Not a fan. I might work on this problem later on. This is a very good sort of brain teaser problem. Each node of the segment tree should store the array sum. Yep. The maximum sub-array sum. The maximum prefix sum. And the maximum prefix sum within the sub-array defined by that node. Okay. Within the array, maximum suffix sum. Oh, wait a second. But how do you delete things? Okay, I gotta think about it a little bit. I think this might be, this is the hint. Maybe that's the right strategy to go. Oh no, not the segment trees. I know, Red Finance. I don't like segment trees either. But yeah, it's time to brush up. It's time to brush up. So the thing I hate about segment trees the most is that Python, there's no library that supports segment tree. At least in Java, you have a segment tree library. Python, no segment tree library. So you got to write your own. You got to write your own and then copy paste it from somewhere else. Okay. All right. I think that's the end of the stream. I'm going to see if I can work on question 4 off stream a little bit, and I might post this video. Yeah. Thanks all for hanging out. Remember to just hit the like button on the stream. It's going to help me out a lot. Add a comment and subscribe if you have not already. Thanks all. I'm going to go. Good night for you who is nighttime, and for those of you who are not, happy weekend. Bye-bye.